Hi everyone, something happened to the last video and I had to just the OneNote didn't work and I had to stop the video, and now I am going to continue. So here I was talking about the percentage, which is 3.8%, and I said when you have percent V over V or percent W over so V or percent W over W, so we want to see the number so over 100 because we want to see it as a percentage. Okay, so we can find the number and then so make multiple top and bottom with 100, or you can say 0.038 over 1 is what over 100, so means X is 3.8%. okay, so because you want to see it as a percentage, so you can do it by just proportion, or you can do it by those steps in the lesson that says when you want to change a number to percentage, you have to multiply it by 100 and then add a percentage symbol. Okay, so all of them work here. So I'm going to continue here. So how much water needs to be added to 8.5 milliliter of stock solution to make a dilution 1 over 20? What does 1 over 20 mean based on what we learned from panel number 1 and number 2? So at the beginning of the lesson, topic 13, 1 over 20 is 1 over 1 plus 19. Okay, so means whatever I add to the top, I have to add 19 of that to the bottom. If I do, for example, y, it must be y over 19y. Okay, so whatever. Okay, so it says how much to be added to that. So it means 8.5 milliliter over 8.5 milliliter plus 19 multiple 8.5 milliliter. This is when you cancel, so when you factor 8.5, and this is 1 over 20. Yes, that's that. Yes, when you calculate. Okay, so it says how much water, so this is the amount of water must be added. Okay, so we need, so the amount of water need to be 19 multiple 8, so sorry, multiple 8.5 milliliter should be water added. Okay, and don't forget you have to write a sentence. You have to write a sentence here, and you have to have the unit. Okay, so the answer is 161.5 milliliter water is needed. Is needed for this dilution. Okay, so how about this? What is the dilution if this stock solution has this solvent added? Okay, listen, it doesn't say this is the solution, it says solvent added. Okay, so solute top and solvent is added. So this is a stock 45 milliliter over 45 milliliter based on what we learned plus 270 milliliter solvent. Okay, this is solvent here, so it means 40, both of them are milliliter. I don't need to do any conversion. I don't need to be worried about that. So this is 315 milliliter, which when I simplify, it's 1 over 7. Okay, so the dilution ratio is 1 to 7, which means 1 over 1 plus 6. So whatever I have, 6 of them are added, and if you calculate 6 of 45 is 270 milliliter. Okay, so that's the answer here. So I just try to make it easier for you to understand here. So recall the lectures on word problems. We talked about mixtures. Okay, so we talked about mixtures, and we had mixtures of two solution Okay, two solution containing the same component. So we added them. So one of them, the concentration was C1, one of them concentration was C2, and then one of them was the volume was V1, the volume was V2, and then we added at the end we had concentration final, CF, and V final. And how do we find V? So it's V final is V1 plus V2. Okay, so sometimes you see this one, you see C1V1 equals C2V2 or C1V1 equals C final V final, and then you say how they are connected to each other. What's wrong with the formula? Which one is correct? Because one of them has C1V1 plus C2V2 and the other side just CFVF, and one of them no, just one side and the one the other side. Okay, so it's not wrong. Both of them are correct. The problem is here, because you dilute with something with no concentration, okay? So here, your concentration is 0, okay? Because your concentration, so for example, I have a cup of my coffee, for example, okay? And then I add 2 cups of hot water. Okay, so I am using water doesn't have any sugar, doesn't have any coffee, so the concentration is 0. Okay, so here will be removed, C2V2 will be removed. So that's why when you do, so you have this formula, original formula, but when you work with dilution, then you have this kind. So one side is C1V1, which is concentration 1, volume 1, and the other side concentration, new concentration when you add water, and new volume when you add the water. Okay, so you can say C1V1 equals C2V2, but this C2V2 is not the same as the other C2V2. No, so or you can say C1V1 equals C final V final. That's understandable because that's the new concentration, final concentration, and final volume. Okay, so let's do this question just with this formula here. Okay, so yes, so if 35 milliliter of first solution, 25% W over V NaCl is mixed with this milliliter of second solution, which is pure water, what is new concentration? Okay, so I want to do it with two formula here. Okay, so oops, if I can make this line here, it'll be good. Okay, so one of them I do C1 V1 plus C2 V2 equals C final V final. Okay, so C1 is 0.25. You know, 25% is mathematically is just a symbol, just a number. But if I want to use it in math, I have to divide it by 100. So 0.25 multiple 35, okay, plus 0 multiple 65 milliliter, because that's water, no concentration, pure. And then I have C final multiple 100, because I have to do 35 plus 65 milliliter. And because I have both of the milliliter, I have no problem here in order to just to be worried about just conversion. Okay, so both of the milliliters, so I don't need, and it didn't say I have to change it to liter or something, so I don't need to be worried about conversion. Okay, so what is CF here? So CF here is, I can find the answer. So CF here, where is my calculator? Okay, CF here is 0.25 multiple 35. Oops. 0.25 multiple 35 divided by 100. Okay, so that's 0.0875, which is 8.75%. 8.75%. And as you can see, and it makes sense, the concentration went down because of course, a dilution means reducing concentration. Okay, so let's say I don't want to use this formula, I want to use the other formula. So the other formula is C1 V1 equals C final V final, or C2 V2. Okay, but you just have to know what is the meaning of each symbol. So C1 is 0.25 multiple 35 equal, this is a question, and this one is V final, which is 100 milliliter. Okay, and that's the same answer. So C final is, new concentration is this one. Okay, so you have to know both formula. So this formula is original formula, okay, and I can make the other formula just because of dilution. When I use solvent, that's zero concentration, so one of the formula will be moved, and then I will be fine here. Okay, so here I can use, maybe because I have room here, I can use this one here, so I don't need to be that much squeezed in a place. So I can do C1 V1 equals C final V final, and C1 is 0.25 multiple 35 equals CF multiple 100, or milliliter, I'm okay. So CF is 0. Oops, CF is 0.0875, which is 8.75%. Okay, so yes, so dilutions that which we use solvent with no concentration, I can use this formula here. Okay, so I showed you both of them the same. Okay, so that's a question here. So the solution here which I used, okay, I can say that's here. So I didn't pay attention, I have to repeat this here, and in order to make it neater I added the question. But okay, so here I can write milliliter and say, yeah, okay, so that's the answer here. So suppose you have 1 liter of a stock solution containing this mole per liter, so that's also concentration. Mole is also concentration. Okay, so mole per liter. Okay, so how many do I have? Okay, so then suppose you have 1 liter of a stock solution containing this mole acetone, but you want a solution containing this mole acetone. What should you do here? Okay, so C1 V1 equals C final V final. Sometimes the students say C2 V2. Again, remember, C2 is not that C2 before, which was the second one. No, C2 is, if you use it the other side, means final. Okay, so C1 is 0.3 multiple 1 liter, and I want 0. This multiple V final. Okay, so you can find that. So V final is this divided by that, which is 10 liter, so how can we do that? So how much do we, so how much, okay, remember 10 liter is the total solution, but how much solvent I added? Okay, so I want to find that. So 10 liter minus 1 liter, so this is total, this is stock, and this is 9 liter solvent. Okay, yeah, okay, so and at the end I can explain 9 liter solvent is added to 1 liter stock. Okay, yeah, okay, so now we move to this question. So okay, so it says many years ago in Bio 273, students were asked to make just one to 1 million dilution. So 1 to 1 million. So if you want to do 1 to 1 million, the same as what we did so far. Okay, so you want to do 1 milliliter over 1 million milliliter, which is 1 milliliter over 1 plus 999 999,999, right, milliliter. So this is not really, I'm not sure, it's not really practical, and it's not really accurate. So, and I don't think it's really feasible to do that. So how can we do that? How can we do something like 1 to 1 million dilution? Okay, so what should we do here? Okay, so the recommendation says, just the lesson which is coming in the next page, that's serial dilution. So we can do dilution and dilution and dilution, so just several dilutions, and then reach to that we need, okay, which will be feasible and more accurate. So I do 1/100, and then I use 1/100 the new solution to do another 1/100, and I use the new one again to use another one. Okay, so then it will be, instead of 1 million, I did three 1/100, and the new dilution ratio will be just 1/100 multiple 1/100 multiple 1/100. Okay, so this is called serial dilution. Okay, so here it may be necessary to dilute by a larger factor, so several times, so you can do several dilution. So how does it work? Okay, so look at this. So let's say you have 1 milliliter here is stock. Okay, this 1 milliliter stock is 1000 microliter. Okay, 1000 microliter. Yes, okay. So I use 10 microliter. I can, from 1000 microliter, which is here, I use 10 of them. Okay, and I add to 990 microliter. So it will be 10 over 10 plus 990, which is 10 over 1000, which is 1/100. Okay, so you see 1/100 and you think it's 1/1 plus 99, okay, but in reality it's not. So maybe I give you this and I don't give you what happened. That's okay, you just have the dilution ratio. But if I tell you what happened, then you know how much it was and how much was added, and at the end, what's that? Okay, so then you can find the dilution ratio. Okay, so this is 1/100. Then I use, so this is related to this part. Then I use 1 microliter of that, and I add 999 microliter. So it will be 1. So maybe I can change the color here. Okay, so 1/1 plus 999 microliter, all of them microliter. Remember, I should have the same unit, so it is 1/1000. Okay, and then in this case I can say I have 1/100 multiple 1/1000. I have 1/100,000 when I multiply. So this will be my clue here. Okay, so if I have several dilution and I multiple all the dilution ratios, then I have total dilution ratio, total dilution. Okay, so I can make a formula here. New concentration will be old concentration or stock concentration multiple total dilution. Then you would say, oh, okay, if I multiply something with old concentration, then it will be bigger, not smaller, but I want a new concentration to be lower because it's dilution, I'm reducing. Okay, listen, total dilution is not just a number, it's a fraction. So it is a ratio. Look at this, it's 1/1000, 1/100,000. So of course it's like divided, and of course new concentration is less than old concentration. Okay, so don't just mix the formula. Oh, okay, what should I do? Yes, new concentration is old concentration multiple total dilution, but total dilution is a ratio. Okay, 1/something. Okay, or maybe another, but it's a fraction. Okay, so we can keep this formula in our mind. Okay, so now if a stock solution of 75% W/V of NaCl is diluted 1/20, and then this new solution is diluted another time, so dilution ratio 1, dilution ratio 2, what is concentration of final? What is new concentration? Okay, So read the question carefully. A stock solution means all concentration. Dilution 1, dilution 2, yes, I have two dilution, I have to multiply them with each other, and I can find total dilution ratio. Okay, so total dilution ratio. So here, what is new concentration? Okay, so new concentration is all concentration multiple total dilution ratio. Okay, so maybe here I can add R to say total dilution, or total dilution, just to total dilution. Okay, so perhaps it's not bad to do a ratio here, total dilution, and yes, here, total dilution ratio. Okay, so new concentration is missing, old concentration is 75%. I can say 75%, and then I have percent, or I can say 0.75, and then I have to change it to percentage. Okay, so this multiple 1/20 multiple 1/30, okay, which is 1/600. So it is, so I can find the answer here. So 0.75 divided by, 600, which is yes, which is 0.125%. Okay, remember, when I keep this percent here, this will be percent. But if I change it to 0.75, then I have to make sure that I need to multiply by 100 to say what is the new concentration. Okay, so this is the new concentration here. Make sure to show me the unit. Make sure to write the sentence, conclusion sentence. If you are doing just a lab report, it's very important that you are able to explain what's going on. Okay, so now you can, okay, you can continue here to this question. Yes. Yeah. Okay, so this question here, so yes, I can do that. And yeah. Okay, so let me see. Oh, yes. Yeah. Okay, a bacterial culture contains these cells per milliliter. This is concentration. That's all concentration. Okay, so you perform 1/1000 dilution, so 1/100 dilution, and 1/20 dilution. How do you do it? We don't know. So we do 1/1 plus 999. I don't know, or something else, but I know just the dilution ratio is 1/1000. Okay, what is final concentration here? What is final concentration? Okay, so first let's find, okay, final concentration. So new concentration is old concentration multiple total dilution ratio. Okay, so not new concentration is missing. New concentration, what is old concentration? 5.0 multiple 10 power 9 is that. Multiple total dilution ratio 1/1000 multiple 1/100 multiple 1/20. Okay, which is, you can find the answer. So it is this, like 5 billion divided by 2 million. Am I right here? Yes, which is 2500 cells per milliliter. How do I know cells per milliliter? Yes, I can look at here. So what do I have? Just as a unit. So that will be my unit then, because that's unit of old concentration. Okay, so that's my last concentration, and now this is new concentration. Now it says how many cells are in 5 milliliter of final solution. See, it says final solution, not original one. So how many cells? Oh, okay, so how many cells I have here? I can do this two ways. I can do this with proportion. So I want to show you both ways. So proportion, I can say, okay, 2500 cells per 1 milliliter. How many for 5 milliliter? Per 5 milliliter. So X is 12,500 cells. Okay, so and here so I can do it by conversion factor to show you. So I want to go from 5 milliliter. Okay, so or I can go from let me see, so so that's 2,500 cells. I want to go to how many cells? Okay, so it's 2,500 cells per milliliter. I want to go just to how many cells? Okay, so 5 milliliter here. Okay, so I can say the same as before. I can say I have 5 milliliter. I want to go to number of cells. So I can say 5 milliliter. I want to cancel milliliter. I want to bring cells. So it is milliliter down, 2,500 cells up. So I can cancel this, and the answer is this is left and this one. And what is the answer? So 12,500 cells. Okay, they're the same, both of them the same. So with proportion and conversion. Okay, so the next question. Okay, so yeah. Okay, so let me see. Yes. Okay, yeah. So now, so you have this molarity concentrated HCl solution. So perform 3 dilutions. So 3 of them. Read the question carefully. Okay, read the question carefully. This is old concentration. You have 3 of them, not just one. So read the question carefully. 3 of them. What is your final concentration? Okay, so new concentration is old concentration minus total dilution ratio, which is 0.50 m, capital M molarity, multiple 1 over 10, multiple 1 over 10, multiple 1 over 10. Okay, which is 0.0005 molarity. So we change molarity from 0.5 mole per liter to this number per liter, which we reduced it. Okay, reduce it a lot. Okay, because we did 1 over 10. So how much diluted? Okay, how much diluent will you require? So diluent means the amount that we added, the amount of solvent we added. Okay, we call it diluent. So how much? Okay, so let's see, what do we see here? Okay, so taking 5 milliliter each time. So this part is for B. This is for B, part B, and this part is for A. Okay, so part B. Because I know I did 1 over 10, but I'm not sure how did I do it. But it says 5 milliliter every time. Okay, so I have this guy. So this is my stock. And this is what I have here. Okay, for example. Okay, so now I get 5 milliliter. How can I have 1 over 10? Okay, how can I have 1 over 10? So 5 over, what does 1 over 10 mean? Okay, 1 over 10, which is 1 over 1 plus 9, right? Which is, if I do 5 milliliter, is 5 milliliter plus 45 milliliter. See, I know 1 over 10, I can say it's 1 over 1 plus 9, but I don't know how much I used in order to find how much I need here. So diluent. Okay, so I told you, if it is X, it's over X plus 9X. If it is Y, it's over Y plus 9Y. Okay, so we don't know that. So we can keep this in our mind, that this is what we need for the first time. And the next time, again, Again, you use another one, 5 milliliter, and again you have 1 over 10. It's 1 over 1 plus 9. It is 5 milliliter over 5 milliliter plus 45 milliliter. Okay, so which is again here what we need for the second time. And then so it is here, it's 50 milliliter solution. Yes, because 5 plus 45. And how do I know 45? Because it's 1 over 10 means 1 over 1 plus 9. Okay, so how about that here? Okay, so another 5 milliliter. Yes, so another 1 over 10, which is 1 over 1 plus 9, which is 5 milliliter over 5 milliliter plus 45 milliliter. This is the last one. Okay, and here I have the last one, which is 50 milliliter. So now if you want to add them, this will be 135 milliliter when you add them. Okay, so I can say, okay, so if it's so this one plus this one plus this one, and the result will be 135 milliliter. Okay, so 135 milliliter diluent, which is the amount which was added. Okay, that's the added one, no concentration. Okay, so make sure to have a unit, make sure to have the sentence conclusion. Okay, so yes, so I do this question, and I can just stop the video and then do the rest in next one. So here, a bacterial culture contains an unknown number of cells. Here I don't know unknown number of cells. I don't know that. You perform 1 over 100 dilution. How do you do it? Is it 1 over 1 plus 99? We don't know. Okay, maybe yes, maybe no. See, it didn't say. Okay, so I have this one, my stock. This one is the amount I have. So I do 1 over 100. How do I do it? I don't know. See, the same as here. Yes, it was 1 over 10, but it was 5 over 5 plus 45. But how do we do it here? I don't know. Okay, so then, so it will be the second one. The second one here. Now I say, okay, so this is the first I did. Number 1. It's number 1. Okay, so then you remove 2 milliliter and add 8 milliliter of water. Remember here it's telling you. Okay, so you do 2 milliliter and add 8 milliliter. So it's 2 milliliter plus 2 plus 8 milliliter. It didn't say the ratio, but you have to find the ratio here, which is 2 over 10, which is 1 over 5. Oh, perfect. I didn't know my dilution ratio, but now I know it. 1 over 5. I found it. For the first one I have, but I don't know how much. Here I know how much I can find the ratio. It's 1 over 10. Sorry, 1 over 5. Because it's 2 over 2 plus 8. Okay? So here I can write meter. Okay, so that's okay. So 1 over 5. So yes, it's equal 1 over 5. Okay. So here we don't know, but here we know it's 10 milliliter. Okay, now it says, so this is number 2. Okay, so see step by step. I read the question, I understand the type. It's dilution question. I need to have the formula in my head, and then I make it step by step easier for myself. You then put 1 milliliter of the final sample in a petri dish and count number of cells, and they are 20. Okay, so that's the last concentration. So I use that. Okay, so where is my 1 milliliter. Okay, and then I do this. Yes, and I have, when I count them, it's 20 cells, right? 20 cells counted. Okay, so this is the third part. Number 3. Okay, so how many cells were in the original sample? Means I want to find the original concentration, right? I have new concentration. Okay, so let's find it. Okay, so I have new concentration equal old concentration multiple total dilution ratio. Therefore, it's old concentration, new concentration divided by total dilution ratio. What is new concentration? 20 cells per, okay, so I have to write in the other line. Okay, so do I have room? Oh, yes. Okay, yes. So I have 20 cells over 1 milliliter. Okay, so divided by total dilution. What is total dilution? So 1 over 100 multiple 1 over 5. 1 over 100 multiple 1 over 5. Okay, yes. Okay, which is yes, so it is 20, let me see. Yes, it's 20 cells per 1 milliliter multiple by 500. So when I can change it to multiple and flip it. Okay, so I have 500 multiple 20. Okay, 10,000. That's 10,000 cells per 1 milliliter. Okay, that was the that was the answer, right? Okay, see, I read the question, I understand it's dilution problem, but I have to do it step by step. I have to break it to different parts, and then I can do it. For one of them I have dilution ratio, for one of them I have to find it, then I have to multiply them, and then I have to see which one I'm looking for. Okay, and then I can find the answer. So here I stop, and